All right, let's talk about wine. But we're not just gonna look at the label. We're diving deep into the liquid itself to uncover this, hidden transformation. It's kind of a second act in winemaking that secretly shapes the entire taste and feel of your favorite red. So think about the last time you had a glass of red wine. Was it, super rich and velvety, or was it more sharp and tangy? That huge difference, it's not just about the grape or the barrel it was aged in. No, it's about this microscopic changing of the guard that happens right inside the wine itself. So what is it? What explains this massive difference in texture and feel? Well, the answer lies in a process that, honestly, most wine drinkers have never even heard of. So let's get into it.
Okay, section 1, wine's secret second fermentation. Look, everyone knows about the first fermentation, right? That's where yeast eats up sugar and spits out alcohol. Pretty straightforward. But for most red wines and even some whites, the real magic, the thing that changes everything, happens next.
And no, it's not actual magic. It's a microscopic transformation that kicks off right after the main event. So once the yeast has done its job and tapped out, this whole new crew of microorganisms takes over. This is where the wine's personality is truly shaped, turning it from this raw, kind of acidic liquid into something way smoother and more inviting. So what exactly is this transformation? At its heart, it's all about a fundamental chemical trade-off. Let's call it the Great Acid Swap. This process is called Malolactic Fermentation, or just MLF for short. And the key thing to remember here is that it's all about bacteria, not yeast, swapping out a really harsh acid for a much softer, creamier one. Okay, to really get this, think about biting into a super crisp, really sour Granny Smith apple. That sharp, puckering sensation, that's malic acid. Now, on the other hand, imagine the smooth, gentle tang of yogurt. That's lactic acid. MLF is literally the process of swapping that sharp apple tartness for that creamy yogurt smoothness right inside the wine. It's an amazing trade. So why on earth do winemakers want this swap to happen? Well, it's not just about softening the wine. It adds all these incredible layers of complexity, and it creates a rounder, fuller feeling in your mouth. But honestly, maybe the most important reason is for biological stability. By letting these friendly bacteria do a final cleanup, you're basically preventing any unwanted microbes from causing weird off flavors or even fizziness in the bottle later on. It's like an insurance policy. All right, section 3, meet the microscopic winemakers. So who are these tiny little guys responsible for such a massive change? Let's meet the key players in this drama. The absolute star of the show is a bacterium called Oenococcus oeni. Seriously, think of it as the MVP of MLF. It's perfectly adapted to survive in wine's pretty tough environment. High alcohol, low pH, the works. But then you have the wild cards, like Lactobacillus. They can do the job, but they're not always as reliable. And that's the real risk here, because if the wrong kinds of Lactobacillus or another one called Oenococcus take over, they can start producing these really undesirable compounds. We're talking about off flavors that you definitely don't want in your wine. Which brings us to the winemaker's biggest dilemma. Do you just let nature take the wheel and hope for the best, or do you step in and take control? It's a huge decision. So you have two paths. On one hand, there's spontaneous fermentation. You're basically just relying on whatever bacteria are naturally hanging out in the vineyard and the cellar. The potential upside, you might get some really unique complexity. But the risk is huge. You could end up with aromas of rancid butter or even sweat. Not great. On the other hand, you can direct the fermentation. You add a specific culture of our hero, Oenococcus oeni, which gives the winemaker almost complete control over the final outcome. And to pull this off, the winemaker has to think like a scientist. They have to create the perfect environment, like a recipe. The pH can't be too low, the temperature has to be just right, not too hot, not too cold, and they have to carefully manage the levels of sulfur dioxide and alcohol. It's this incredibly delicate balancing act. This quote from Morenzoni really says it all. If you let MLF just happen on its own, you are literally handing over complete control of your wine's quality to a random microbe. With the stakes being that high, it's really no surprise that most winemakers today choose to direct the whole process. Okay, so how does this super microscopic process connect to one of the biggest challenges of our time? Well, let's zoom out and look at the bigger picture. Winemaking in a warming world. The connection is actually pretty simple and direct. A changing climate means changing grapes. As the world warms up, it's altering the fundamental raw material of wine, and that has huge knock-on effects for the wine's chemistry. So here's the chain reaction that's happening. Warmer weather means grapes ripen faster. This leads to more sugar, which is fine, but also less acidity. And that lower acidity means the wine ends up with a higher pH. Now, why does that matter? Because a high pH wine is way less stable. It's basically an open invitation for all kinds of spoilage microbes, which massively increases the risk of defects and funky flavors.
So, how is science adapting to this new reality? Winemakers are coming up with some really fascinating new strategies. For example, some are now using specific strains of Lactobacillus to actually increase the acidity before fermentation even starts. Others are co-inoculating. That means they're adding their chosen bacteria at the exact same time as the yeast to make sure the good microbes get a head start and win the race. It's pretty clever stuff.
So the next time you pour yourself a glass of a really smooth, complex red wine, just take a second and remember what you're really tasting. It's this incredible blend of ancient art, cutting-edge microbiology, and a direct response to our changing planet. The only real question is, which of those will you notice first?